Okay, so now we're going to work through a few examples here just to make sure that those ideas are clear to you. If we were asked then to sketch an angle of 270 degrees in standard position on the Cartesian plane, we would begin by marking our initial arm, which is always placed along the positive x-axis, and rotating counterclockwise by 270 degrees would take us all the way down to the negative y-axis. So there's our 270 degree angle. Now the next example asks us to plot an angle of negative 45 degrees. When that happens, it seems quite curious to have a negative angle. What on earth does that mean? The negative is indicating that we need to rotate in the opposite direction. Okay, so when dealing with a question like this, let's just make a side note here. The negative means rotate clockwise. Okay, so that gives us a way to differentiate between direction of rotation, which of course becomes quite important. Think of a spinning wheel. Whether that wheel is rotating forward or backwards does make a difference to where your car drives. So we need to have a way to mathematically represent that at times. Okay, so a negative angle indicates that we're rotating in the opposite direction. So negative 45 degrees. Now our initial arm would still be along the positive x-axis. And that should be right along the positive x-axis. Okay, it's not really supposed to be above it the way it's showing there. That's just because my writing is not so great with this app just yet. Negative 45 degrees, though, would be halfway through quadrant 4 in this direction, rotating in this direction. So negative 45 degrees. Okay, and the last example is 120 degrees, starting on the positive x-axis and rotating 120 degrees would be 90 degrees to the positive y-axis, so we need to go 30 degrees past that. So we'll just estimate approximately where that would be. Oh my goodness, I did not do the greatest job of this one. Let's see if we can fix that up a little bit. But I think you hopefully get the general idea here. Goodness, there we go, 120 degrees. Okay, the next idea that we are going to review or look at is the idea of a reference angle. Now it says here, for any angle in the Cartesian plane, the reference angle is the positive acute angle between the terminal arm and the x-axis. The positive acute angle between the terminal arm and the x-axis. So for example, the reference angle for an angle of 135 degrees is 45 degrees, as you can see in the picture. Now let's go through a couple of examples of finding the reference angle. So it says find the reference angle for each angle given. So 210 degrees. Let's begin by plotting an angle of 210 degrees on the Cartesian plane. Well, an angle of 180 degrees would take us to the negative x-axis. Now, 210 degrees is 180 degrees plus 30 degrees. So sometimes it's helpful to think of it that way, because it means from 180 degrees I would need to go at about 30 degrees further. So here we would have an angle of 210 degrees. And remember, the reference angle is the positive acute angle between the terminal arm and the x-axis. So that would be this angle in here, okay, is the reference angle. So the reference angle for 210 degrees is 30 degrees. Remember, it was 30 degrees. We had to add on to 180 to get to 210 degrees. So 30 degrees is the reference angle then for 210. Now, 320 degrees, if I was to mark that one on the Cartesian plane, 320 degrees is just 40 degrees shy of 360. So if we think of it that way, it means that I would want to rotate all the way around, but stop when I get to 40 degrees before 360. Okay, and that tells me then that the reference angle for 320 degrees is 40 degrees. Okay, and so 40 degrees is the reference angle for 320 degrees. Now, one more definition for you here is that of related angles. Related angles, it says, are angles that have the same reference angle. So in our next example, we're going to look at the related angles, or some of the related angles, for an angle of 30 degrees. So we can mark 30 degrees off in our first quadrant here. And now any angle related to that would also have a reference angle of 30 degrees. So for example, in quadrant 2, if I have an angle in quadrant 2 with a reference angle of 30 degrees, then the measure of that angle would be 180 degrees minus 30 degrees, so 150 degrees. So again, both of these little acute angles in here measure 30 degrees, although my picture certainly doesn't show it very well. Now in quadrant 3, if I was to draw a terminal arm indicating a reference angle of 30 degrees, then the measure for this complete angle would be found by adding 30 degrees to 180 for an angle of 210 degrees. Okay, and finally in quadrant 4, if I was to draw an angle of 30 degrees there as my reference angle, then the measure of this rotation angle would be found by subtracting 30 degrees from 360, because a full rotation would be 360 degrees. We are just 30 degrees shy of that, so the related angle in quadrant 4 would be 330 degrees. So we could say 3 related angles for 30 degrees are 150 degrees, 210 degrees, and 330 degrees. And again, in the coming lesson, I'm going to show you how we can then use the idea of the special triangles to find the exact trig ratios of angles such as this one, angles which are related to a special angle. Okay, and 30 degrees is one of those special angles. But we're not quite there yet. I just wanted you to know where this is all sort of heading. Now, the last idea we're going to review in this lesson before you do some practice questions is the idea of coterminal angles. Okay, coterminal angles have the same terminal arm. So the question says list 4 angles that are coterminal with 60 degrees. So not just related to 60 degrees, but coterminal with 60 degrees. Now, a 60-degree angle has its terminal arm in quadrant 1. Okay, so if we are to find any angle coterminal with that, well, for example, I could start at my initial arm, rotate completely 360 degrees, plus an additional 60, and then I would land on in the same positioning with the terminal arm. So one possibility would be 60 degrees plus a full rotation of 360 degrees for an angle of 420 degrees. So 420 degrees and 60 degrees are coterminal. Another option would be to rotate in the opposite direction. So start with my initial arm on the positive x-axis and rotate clockwise. That also would give me an angle coterminal with an angle of 60 degrees. And the size of that angle would be found by subtracting 360 degrees from 60 for an answer of negative 300 degrees. And I did expect that one would be negative because, remember, we're rotating in the opposite direction. We were rotating clockwise as opposed to counterclockwise. So there's a second coterminal angle. And basically I could repeat either one of those as many times as I wanted, rotating in either direction. So what I mean by that is, for example, we could rotate in a counterclockwise direction 2 complete rotations. I don't know if I can actually show that very well without really botching up your picture here, but we would go 1 complete rotation, then another rotation, and land in the same spot. In other words, adding on 720 degrees of rotation to our initial 60. Sorry, that should be an addition, not an equal sign. Okay, for an angle of 780 degrees. Or I could do the same thing in the opposite direction. So instead of adding 720 degrees, I could subtract 720 degrees, indicating that I'm rotating clockwise by 720 degrees, 2 full rotations, for an angle of negative 660 degrees. So there we have 4 angles that are coterminal with 60 degrees. And that completes lesson 1.